So, I'm going to teach you a bit about lambda angles before I do any questions. Imagine a horizontal plane, okay, XY axis, right? And I throw the particle up, and then I get the time of flight. Everybody happy? I find the time of flight using SY equals 0. Yeah. I insert that time of flight into Vx and Vy. What will happen when I put the time of flight into Vx and Vy? It will tell me the speed at which it hits the ground. So, for example, at the time of flight, for argument's sake, let's say it's going across at 10 and down at 20. Everybody cool with that? Across at 10 and down at 20. And I define the angle it hits the ground. See that angle A? Or technically angle L for landing angle. Okay? And what I'm looking to do is find what angle is that. Now, there's an issue in your calculator. It won't spit out Vy equals 20. It will spit out Vy equals minus 20, and it'll spit out Vx equals 10 for argument's sake. You go to your calculator and go, no bother. And what you got to remember is when you're tan inversing this, you're tan inversing plus 20 and 10. So you go shift, tan inverse, up to over adjacent, 20 divided by 10. Make sure you're in degrees mode, and you're like, okay, no bother. That's a landing angle of 63 degrees. So tan L is equal to minus Vy over Vx, because you always have to adjust the Vy value to be positive for tan to work. Good so far? Alrighty. Now, this question here, we have a standard question with the inclined plane. And we throw it upwards, and it hits. Now, there's some sneaky ones, okay? So I'm going to show you two examples of special cases, okay? The first special case is you lob it up, and what happens is you land directly, oh sorry, that's a bit over exaggerated. Again, you land directly at 90 degrees with the plane. So everybody get that's the landing angle is 90 degrees? Everybody cool with that? What's the special case for if the landing angle is 90 degrees? You only have a Vy, but your Vx is 0. So if you see the word lands perpendicular, special case for Vx equals 0. Okay? So that's the plan. At the time of flight, Vx equals 0. That's your way into that question. The next special case is when you land horizontal you land parallel to the horizontal. So in a case like this, imagine this is a 50-degree plane. I throw the ball up or whatever object it is, and then as I hit, it's going directly across. Can I tell you what the landing angle would be in this case? Alternate angles, it would actually be 50 degrees. So, in the case where you're traveling horizontal when you hit the plane, your landing angle, L will equal angle of plane. So, minus Vy over Vx would equal tan B. You know, like B is usually your plane angle. Does that make sense? So that's when it's traveling horizontally and when it hits it perpendicular. There are your two special cases. Every other case is pretty standard maths. Okay. So is this a special case? Is the first thing we got to ask ourselves. Is there anything in the writing to say that it's special? No. Okay. 30 degrees to the horizontal, to the plane. So there's nothing special to be done here. So that's going to be 30 degrees. And down. And that's also 30 degrees. Okay, gravity triangle. G cos 30, G sin 30. So root 3 over 2. G and half G. Is that okay with you guys? G over 2G and a half G. Okay, show that the angle is 3 degrees. So I write down tan L for get me some nice marks here. Vy over Vx. Alright. Vx, anybody? No, I haven't done my, does it tell me how fast I'm throwing at? Just U, isn't it? So U cos 30 and U sine 30. So it's root 3 over 2U and U over 2. So it's going to be root 3 over 2U minus a half. No, not a half. Oh, sorry, minus a half GT. Yep. Py is U over 2 minus root 3 over 2 T. Sx equals root 3 over 2 ut minus a quarter squared. And finally sy is going to be u over 2t minus a root 3 over 4 squared. All right, pause it there. Sort of check these ones first and make sure that they match up to the xy direction. Then after I check that, I then go to my gravity triangle and go, that's the one in the x direction, so I make sure that it's there. Then I half it, so half of a half is a quarter, and the extra t is added on, so I'm happy with that. And finally, I circle this one and go, okay, that's it there. Then I half it, and now I'm happy. You gotta do that check. Okay. Now, what are we looking for next? We're looking for the landing angle. So we need Vx and Vy at time of flight. So let's find the time of flight. Put this equal to 0. U over 2t equals root 3 over 4 gt squared. Cancel the t's. Time of flight equals 4u over 2 root 3. It's the same thing as 2 over 2u over root 3. Is there g somewhere? Yeah. Alright, we got the time of flight. Now we're going to insert that into the Vx and Sx formula, okay? So Vx, this nonsense here. Oh, sorry, the Vx and Vy formula. Alright, let's drag these two down. Alright, so Vx is going to be root 3 over 2u minus a half gt 2u over root 3g. Okay, g's cancel. 2 cancels that. I'm going to get root 3 over 2u. Take away u over root 3. Alright. No bother. Lob it into the calculator. Root 3 over 2 take away. Yeah, root 3 over 2 take away 1 over root 3. Root 3 over 6, I'll take that. Okay, no bother. Root 3 over 6. Alright, happy days. Now Vy, same deal. U over 2 minus root 3 over 2g times 2u over root 3g. Lads, Phy, positive or negative? Why does it have to be negative? Hitting the ground, isn't it? If Vy is not negative, you are in serious problems. Okay? So it needs to be negative every time because you're hitting the ground. So if it's not negative, you're in trouble. Cancel, cancel. Perfect. U over 2 minus U, which is going to be minus U over 2. Finally, your Lambda angle looks something like this. There's your L value, and it looks like root 3 over 6U, and this is going to be U over 2. See the way I'm ignoring the negative? Okay, so tan L is equal to U over 2 divided by root 3 over 6U. The U's don't matter. So it's basically a half divided by root 3 over 6. I'm going to be pretty lazy about this. I'm just going to tan inverse it off. Tan inverse, what's it, a half? Half divided by root 3 over. And close down. 6 degrees. So L equals 6 degrees. Okay with that? Alrighty. So, you guys look at question 6. Any special case here? You guys start. Will somebody do me a favor and call me out Vx, Vy, Sx, and Sy when you get a chance? So, I think tan, tan beta equals a half. This means cos beta, we're talking about a 1, 2 root 5, are you? 1, 2 root 5, so cos beta is 2 over root 5. Sine beta is 1 over root 5. Yeah. Ah, that's great, isn't it? Now, did anybody else? You don't know the throwing angle, okay? So that's no good to us. So, does anybody have the formula? Ready to go? Right. Oh then. So, I took tan inverse a half. I wrote down tan beta equals 1 over 2. Cos beta equals 2 over root 5, and sine beta equals 1 over root 5. I can now establish the gravity triangle by yeah, so this. Now we know that's beta. We know that's beta. So we know that's going to be g cos beta, so that's going to be 2 over root 5g. And the other one's going to be 1 over root 5g. Everybody cool with that? The thrown angle is going to be what, guys? Thrown angle is going to be, anybody? Theta, isn't it? So u cos theta and u sine theta. Now we got to get our 4 equations up and running. So down here. Okay, let's do it. Px is u cos theta. Take away 1 over root 5 gt. Anybody get that one? Anybody get that yet? Before me? Yep. Next one, u sine theta minus 2 over root 5 gt. Sx is going to be ut cos theta half the sec 1 minus 1 over 2 root 5 gt squared. No bother. Next one after that is going to be ut sine theta minus, now I got to half this, so this here needs to be halved, so it's going to be 1 over root 5 gt squared. Alright, special language in the question. Special language is the paragraph strikes the plane parallel to the horizontal. So what does that mean? Lambda angle equals beta, which means tan beta has to equal minus Vy over Vx. But we know what tan beta is. Tan beta is a half. So that in turn will equal a half. So we have exactly what we need to get this question done. Get the time of flight, insert the time of flight into Vx and Vy, and then sub them into that blue equation. You should be good to go. All right, let's keep going. So let's do Sy equals 0. This equals 0. We're going to get ut sine theta equals 1 over root 5 gt squared. Then we're going to get time of flight, TOF, ends up to be root 5 u sine theta over g. And we get the time of flight ahead of me. Same one. Alright. Insert that to Vx and Vy now. So I'm going to grab these two formulas here. LD. Oh dear. Alright, let's bring them down. There we go. There's the two formulas I need. This side. This side. Alright. Alright. Now, Vx. U cos theta. So it's going to be U cos theta. Take away 1 over root 5 g. And now I have t here, which is going to be root 5 u sine theta over g. G's cancel. Odd enough the root 5's cancel as well. So we're going to be left with Vx equals u cos theta minus u sine theta. Please remember, Vy has to be a guaranteed negative. Got to be no if, but, or ands about it. It has to be a guaranteed negative, otherwise you're wrong. So Vy equals u sine theta minus 2 over root 5 g, and then slot in your t value, which is root 5 u sine theta all over g. The root 5's cancel. The g's cancel. It's actually u sine theta take away 2u sine theta, which is guaranteed negative of minus u sine theta. Because it was u sine theta take away 2u sine theta. Now we know what Vx and Vy are. So now we know what minus Vx over minus Vy over Vx is going to be. It's going to be u sine theta divided by u cos theta over u sine theta. And that has to equal a half, isn't it? You can cancel all the u's if you want. They can all go. I'll just highlight them instead. This means I'm cancelling them, okay? They're gone. Cross multiply, you get 2 sine theta equals u cos theta minus u sine theta. 3 sine theta. Oh wait, no u. 3 sine theta equals cos theta. What now? Bring cos theta underneath. So you get 3 sine theta cos theta equals 1. Bring the 3 underneath, you get sine theta over cos theta equals 1 over 3. And what is sine theta over cos theta? Tan theta equals 1 over 3. What was that? Just